All right, let's minimize that. All right, so let's create a project for this, and I'm not going to create a web project. I'm just going to keep it simple. It'll be just a simple Java project, and so I'll create here. So mapping XML to Java data model. Next, we say finish. Okay, so in there, let's first create a data model, right? We could say new class. Let's create. Let's see. The package we'll put under edu.neu.cs5200 XML to Java. The topic, and we'll create a model. Under the model, we'll create. Let's see. We'll create departments and employees. Okay, we can say that a department has many employees. All right. Okay, so we'll say create first a department. We'll say, and a department has. Let's see, what does a department have? A department has a name, right? So let's say private string name. And let's keep it really simple. So we'll create a setter and getter for that. We'll say OK. Here we go. So we have a department. Okay. And what we want to be able to do is, if I have this object, if I have an instance of a department, perhaps read from a database, and I need to send it to someone as an XML document, I need to be able to convert this, right, into an XML representation. Right? And vice versa, right? If somebody sends me an XML, right, I need to convert that XML into a Java representation so they can then perhaps persist in my database, right? So I need to. So this is the conversion layer, right? So let's do that. So what we want to do, if this is going to be converted into XML, right? We need to use. We have to annotate it, just like when we annotate a class that needs to be stored in the database. How do we annotate? We annotate it with entity, yes? Here, if something's going to be converted into XML, right, it needs to be annotated accordingly, right? So this is presumably the root, the root element of our XML document. Okay, right, and then let's leave it like that. Right? Okay. And how about we create a company that has many departments? Right, so we'll do something very hierarchical. We'll say, here's a company, and the company has many departments, and each department might have many employees. Right, so let's do a fairly deep hierarchy that is well normalized. Right. So let's create also here another one. We'll say new company. We'll say company, right? And we can say that this is also going to be a root, XML root. Notice that everything in all the annotation that we're using are under the following package. See, it's under javax.xml.bind.annotation. Okay, that package belongs to an API that is Java's API to be able to work with XML in general, right? Which is called JAXB, right? A Java API for XML binding. Binding as in, how do I bind Java data models to an XML data model, right? Let's create a binding between the two, right? So yeah, so this is going to be a root element, and this might have many departments, right? So this might have a name, right? So it might have a private string name for the company, and you might have several departments, so a list of departments, right? Okay, we need to import list. No. Okay, we have a list, and we'll say create the setters and getters for this. So we'll say setters and getters for both of them. Okay. All right, so we have a data model, right? It's kind of like a one-to-many, right? Company has many departments, right? All right, so we have enough of that. Let's create something else here. Let's create a DAO that can convert this into an XML representation. So we'll say new class, and not in the model. We'll create it in the DAO, data access object, and we'll create here a company DAO. Okay, and we'll create main. So we'll do all our testing here. So we don't lower this. We'll do all our testing here. So what I want to be able to do is, in here, I like to be able to say, well, if you give me an instance of a company, I would like to be able to convert it into an XML file. Or if you give me an XML file, I like to be able to convert it into a company instance. I like to be able to do vice versa, right? The conversion between these two worlds, between the, here's someone sending me an XML document, I want to convert it into a Java data model, or vice versa, I want to convert the Java data model and send it back, right? This is kind of like the, we're writing something that is very similar to what the ORM does, right? In the ORM API, we use the entity manager, right? The entity manager has APIs such as .persist, right? .merge, .find, yes? That is the API of the ORM. Okay, over here, the conversion is not going to a database, but it's going to persist it as an XML document, right? That we can either send over a wire, so stream it over to someone who needs it, right? Or we're receiving it as a stream. Okay. Right now, we're just going to use a file system, just streaming that to a file system. But later on, we can look at, well, how about a data model that somebody gives us, through a wire, right? Sends it over, or we go and fetch an XML document that is over an HTTP request, right? So we can look at that too. Let's do this one first. Okay. So here we'll say void persist to XML file, right? So we would like to pass it an instance of an object such as company, right? And we'd like to tell it where do we want to store it, right? So for instance, it might be string file name. Okay. So what we'd like to do is instantiate a company and say, well, first we'll create a company DAO, company DAO, new company DAO, okay, and create an instance of a company. New company. Company. There we go. It's asking me where is it and why doesn't it find it? Company. No, it's right, right? Import edu model. Okay, that should be okay, right? And let's set the name. So we'll say company dot set name Acme. Okay, and what we'd like to be able to do says, okay, well, persist DAO dot persist to XML company, and the file name will be, I don't know, company dot XML. Right? I'd like to persist it there. All right, so how do we do that? Well, to do that, we need to get a hold of, as I said, the API is JAXB. Well, that is the API. As we've seen throughout the course, right, there's always an entry point, right? We see that the entry point in ORMs is the entity manager, right, which we get from a factory, right? The entry point to JDBC is a driver manager, right? The entry point for a JSON, and depending on the API you're using, it's the object mapper. Here it's the JAXB context. Okay, JAX-B context is what allows us to start using the API to do these conversions. Right? So we'll call this JAX-B, and the way we get a hold of it is JAX-B dot new instance, and we have to tell it what object, right? What class are we working with? What is it that we are persisting or reading from the file system, right? Or from a stream and we're going to be working with the company.class. Right? We need to tell it what the class is so that it can look at this, it can parse it and see, oh, okay, you have two attributes here. I want to look at the schema. I want to look at the schema so that I can generate an XML equivalent to your Java schema. Okay, so that's what we're providing here. We're saying that is the schema. Right, we're giving it the schema so that it can know how to convert it. We'll go surrounded with try catch. Right. And JAX-B can work both ways. It can have an instance of a Java object and generate an XML document, or vice versa. You know, give it an XML document, it can generate a Java instance. Right, very much like the ORMs. Right, that's what the ORMs do. You give it a Java instance. What's it do? It either does an insert or an update or delete, right, into the corresponding SQL schema, right, and vice versa. It can read from the schema and give you a Java instance. Same thing like the object mapper in JSON, right? It can go both ways. I can give it an instance of a Java object, give it JSON string. So anyway, so let's see. So the process of writing an XML document or of converting anything binary, right, anything in RAM, right, into some streamable format, right, is called, in general, is called marshalling, right, to marshal, right. It is converting some binary proprietary representation into a something that can be persisted or stored permanently. Okay, so we need a marshaller. Right, we need a marshaller. So let's grab a marshaller. We can say JAX-B create. We can create either a marshaller, there it is, so that we can write the XML document, or we can create an unmarshaller, which you get that it's backwards, right? It's here's a file and convert it into an object. We're going to go the way from an object to an XML document. Okay, so it's this one, create a marshaller. There it is. Okay. And so we need an instance of that. So it's marshaller inside of javax.xml.bind. So this is the marshaller. Okay, we have the marshaller. And then we can say, okay, well, now that I have the marshaller, I want, hey, marshaller, I want to marshal this this object, this instance company, into the following file. New file name. Okay, I need to load file. That's it. Right, that's all it takes. All right, ask for a marshaller, and you marshal to a file. Okay, let's see, what object are we selling it? A company just has what? It just has a name. That's all it has. Right. So let's see what this does. Let's run this. No, not Maven. Run it as a Java application. All right, it did blow up. That's good sign. So it should have wrote the XML document somewhere here. So let's refresh this. There it is, company.xml. Right. So let's open it up. So it generates. So here's the XML document, and we can format it. There it is. So it generates. Notice that it generates an XML document with the proper heading, right, for the declaring this as an XML document, the proper root company, and then for the attribute name, it generated an element name. It uses the convention, a naming convention based off of the names of the attributes, right? So for instance, for company, it uses the lowercase, all lowercase company. For the attributes name, it generates an element name. So it maps this. It doesn't have a value for departments, so it didn't generate any departments. Okay, let's put some departments in there. All right, so let's put some departments. So that's the company. Let's create a couple of departments. So department HR. So new department. We'll say HR.setName human resources. And we'll create another one. Department sales new department. And we'll say sales.setName. Okay. And if I want to set it to the company, I need to put it in a list, right? Because that's how company gets a hold of the list of companies, of departments. So let's put this in a list. Let's say list of departments is equal to a new array list of department. Need to load the array list. Okay. Where is it? There it is. Where'd it go? Did it load it? No. Import it. Okay. Where is it? There it is. So I'm actually going to bring all the classes in util, which includes list. There we go. So we have the departments. Now we're going to add the two departments to the list. Add sales, and then add departments that add HR. And then we can say company set department list to be departments. There we go. Now let's run it again. Right now it does have an entry for departments. Right, so let's run this again. And let's read company again. Let's format it. There we go. So notice that what it did is that it created an instance element for name, right, and then an instance for an element for each one of the departments. Departments and the name in there. You see that? Yeah. So it makes sense. And we can go a little further and create some employees. All right. So let's create some employees in the model. Let's say new class employee, and employee might have private string first, private string last, and private string date of hire. Oh no, not string, date. Java util, and private float salary. Okay, and for this we'll create setters and getters for each one of these. And this is also going to be annotated as XML. Okay, let's see. So we'll create a couple of employees for HR. So let's see, employee Alice, new employee. We say Alice dot set first name, Alice dot set last name, Wonderland. Alice dot set salary. Makes a lot of money. Oh, she wants a float. Okay. And then Alice dot set date of hire, new date. Okay. Okay, we got Alice. Let's create one more for Bob. Bob, and this is Bob Dylan. Does Bob make more money? Okay, we got 2 employees in there, and let's create a list of employees. List employee, new array list of employees, and we add those employees that we have. Add Alice, and then oops, and then we'll add Bob. And we'll add them to the to where? To the HR? No, we'll add them to sales. We're good salespeople. They know how to sell themselves, huh? So we'll say sales dot set. Oh wait, what happened? Oh, we need to add a list, right? The department needs to have a list of employees, right? So let's go to back to the department and add that, right? So this will be private list of employees, right? Employees, and we'll add the setter and getter for the employee, right? And we don't have a list, so let's include that. All right. Now we can go back to the DAO and say sales dot set employees to employees. There we go. Notice that we, as far as we're concerned, we are working with a Java data model, just like a plain Java object, right? We're not doing anything special here for it to be XML, right? As far as we're concerned, it's just a plain Java object, right? It is the JAXB API that is going to look at those instances, right, of that particular instance, and then it's going to do all the binding, all the mapping between the right data types. Okay? So if we run this again, right, it didn't blow up. So let's open up company XML. Let's format it. So there it is. So here we got company has several departments, right? It's got in that department. Here are the employees, right? Here's the sales. The name of the department is sales, and here we have the employees in that department. All the other ones don't have any employees, right? Notice that the human resources department does not have any employees. It does not have the employees instances in there. Make sense? Yes? All right. Okay, so we've shown how to go from a Java data model to an XML data model, right? We want to go the other way around too, right? Say we already have an XML document like this, right? We would like to be able to bring it into Java so that we can do some pre-processing, maybe persist into a database, right? Search through things, do some programmatic manipulation of this, right? So let's go the other way around, right? So that's persist to XML. Let's I'm going to comment that out, right? I don't want to persist anymore. I don't want to persist. I want to go the other way around. That XML document that already exists, I want to parse that into my object model, right? So that company.xml, I want to parse it. So we'll say here, we want to write, not persistent XML, I want to public company, right? I want to parse from XML file, right? So I'm going to give it the file name, right? And I want you to parse that file name and give me back an instance of a company with all the departments and all the employees that are in that XML document. Make sense? All right, so let's do that. All right, the code is very, very similar, right? It's almost the same. Like it starts off with a Java context, a JAXB context, sorry, JAXB. JAXB context and new instance, and the schema, the Java schema that we want to work with, right? So we're working with a company, that class, right? And we need to put in a try catch. And then what we want to do is, instead of marshalling and writing to the file system, we want to unmarshal, right? We want to parse it from an XML document into an object, right? So let's do that. Let's say that by default, right, if anything goes wrong, we're just going to return null, right? If there's a try catch and something blows up, we'll go into this return and just return null, right? But if we are successful within the try catch, we will return an instance of a company. Okay. So we need an unmarshaler. Let's get a hold of an unmarshaler. So unmarshaler, unmarshaler. From the JAXB context, JAXB.create unmarshaler. There it is. And we need to import the unmarshaler. And now we're going to use the unmarshaler to unmarshal from a file. And we got the file name right here, right? So we can say new file name. Okay. And what this returns, it returns an instant object. See an instance of an object? Well, if it's parsing, if it's an unmarshaler that knows how to unmarshal a company, what it will return is an instance of a company. Right, that's what's going to return. So we can just say return. Right now, it's complaining that what it's parsing, what it's returning, it's an instance of a generic object. Right, so we need to cast it into the right data type. So we're going to say, all right, add a cast to a company. There it is. Okay, so it's going to cast it and then just returning as an instance. So here at the DAO, we should be ready to say company, parse following file, course.xml, right, and parse it into an instance of a company, right? And if everything goes right, we should be able to print the name of the company. Right, so this should print Acme, right? So if I run this, yep, and it dies. Uh-oh. Parse, blah, blah, blah. File not found. Company, did I spell it right? Oh, sorry. I hate computers. So little. Company. There it is. It prints Acme, right? And just to prove that it's that XML document, right, we can change the name of the company, right, to, I don't know, ABC. We run this, so it's ABC. So it is reading that XML document, right? We can get a hold of the departments, right? So we can say, for department in company.get departments. We can print out the names of the departments, right? So system.out and it prints d.get name of that department, right? So if we run that, we should get those two departments, right? Sales and human resources, right? And we can change it in the XML. That's what's beautiful about having an XML representation of the data, right? Right, that I can go here and change this, right? I don't want this to be the human resources or the sales. I can change the name right here. I can say that this is actually the engineering department. Okay, and if I run this again, right, there it is, engineering. I can go in and mock with the data representation, the persistent data representation. Okay, for each department, I can iterate over the employees inside of the departments.get employees, right, and spit out system.out.println, employee.get get first name, and we'll do a salary, get salary, and then finally maybe start date or hiring date. There we go. And so if we run this again, human resources. So we're okay with Alice, right? We did Alice. All right. So presumably, okay. So get employees, right? It's null, right? So it's null. So that's why this is failing. So what we could do, right? If d.get employees, right, is not null, then do that iteration. All right. So let's do that. There we go. So there we go. Engineering, Alice and Bob, and human resources had no employees. Make sense? Right. So yeah. So there's a 25 words or less on JAX-B. Basically, what is it? It's an API that allows you to do the conversion between the XML data representation and a Java data model representation. Right. So we solved the first part. Right. The part, this boundary between the object world, right, and the XML representation world. Now here we're interacting with a stream that is a local file, right? We could just as easily interact with a stream from a company, right, that is providing those XML, right? We can go fetch the data, or the fetch can be pushed to us, provided to us. Let's go fetch some data. Let's go fetch some data. Some XML. I believe I have some data here. Search for Flickr API. Flickr. No, I don't have it here. Where do I have it? I was playing around with it the other day. Oh, here it is. I think I have it here. I have it here. Copy. So let's close that. So say, all right. So if we have this URL, let's create here. Model. Let's create here a DAO, and we'll call it the Flickr DAO. Right. This is an API that can be useful to talk to Flickr. Right. Flickr can provide data in two formats: either XML format or JSON format. Okay. So let's create here a class. We'll call it the Flickr DAO. Okay. Let's paste this string here, and this is a URL. I'm gonna copy this, and we can go to Flickr and paste that URL here. Hello. We can generate quite a lot of XML here, right? And notice the data model. The data model is what? We have a root XML, right, element called RSP, which I believe stands for response. And then underneath, it has another object called photos, which seems to be all by itself, right? And under there, it looks like it has quite a few instances of photo, okay? Now notice that some of them are attributes like this, right? Stat, that's an attribute, see that, right? But photos is an element within RSP. You see that? Right, so this RSP has two things. It has elements that are attributes and elements that are children. Yes? Photos, same thing. It has quite a few attributes, and then underneath it has quite a few children, photo children. Yes? So let's do this one first, RSP. Okay. So we're going to need a Java data model, right, that can map to this. Right? The example that I gave you is we were generating the XML and we were parsing our own XML. Yes? But what if we don't have the XML, right? Somebody's giving us that XML and we need to parse it to manipulate it. So let's do that. Let's create here in the model. We'll create a RSP data model, right? Following the data model from Flickr. All right, so we'll create a Java called RSP. Right? And it has, this is going to be our root element, right? It has a XML root element. It has, let's see, what attributes does it have? It has stat, that's an attribute, right? But it's a, I'm sorry, it has photos as a sub attribute, right? So it's a sub element, and it has stat as an element, right? So let's declare that. It has private string stat. Okay, let's do this one first, all by itself. Okay, we'll need a setter and a getter. Setter and a getter. We'll just do this one first. We'll say okay. There we go. Now this is unlike ours that all these are elements. That's a default. The default is that it assumes that company has as a child a name element, and that it has many department elements. Right? That's the many because it's a list. Yes, and that's what the XML is. Right? It has one name element and many department elements. You see that? Right? Over here, the elements definitely has this element as a child, but it has this one also, this attribute. But this attribute is not an element. You see, that's an attribute. So we need to tell it, hey, this is not an element under you, right? It's an attribute, right? So we need to tell it that distinction, right? We need to say, hey, RSP, that stat, it's an XML attribute. An XML attribute. Okay, it's not an element, it's an attribute. Okay, and parse it as such. Parse it from the attribute list, not from the element list. Okay, let's go back here. So what we're going to do is, I'm going to say, what we'd like to be able to do is for us to receive an instance of a response, an object of the response, and you know, retrieve response from Flickr, right? From Flickr, yeah. And using this URL, okay? Now this URL had a filter, which I was filtering for keywords for avatar, right? And so you can search for pictures, right, based on a keyword, right? I have a hard-coded name for this. I have avatar. What we could do, right, instead is put like a keyword here, keyword, and then replace that keyword with something, right? So we could say maybe string keyword. Okay. Worst case scenario, we return a null, right? And now the URL string is string. Actually, this will be a constant. This will be something like URL string. Okay, and this one is going to be a constant, so final. Can't change that. So the URL string that we're going to use is the constant URL string with replacement of this keyword. I want to replace that with the actual keyword that you are passing me. Keyword. Okay. Let's try that. Let's try that, and let's print for now. Let's print system.out.println the URL string. URL string. Okay. So let's run this. So public static void main string args. Create an instance of the DAO. Oh, what is it complaining about? Okay, import that. So let's create an instance of the Flickr DAO. So Flickr DAO DAO new Flickr DAO dot retrieve. Let's run that. The keyword, I don't know. Let's search for Titanic. Okay, and let's run this. Let's see what this does. Let's see if this blows up. It should just print out a URL, right? To the command line. All right, so let's do run as a Java application. Yep, there it is. So that's the URL. Let's see if Titanic. Okay, it worked. Photo search key. Okay, that's my key. Please don't reuse my key. So if I paste that here, it should still work. Okay, the URL is good. Before you go further, you should always make sure that the URLs that you're using to talk to any APIs, that those URLs are good, okay? The URL looks like it's good. All right, so now we have the URL. We can go fetch the XML. Okay, let's fetch that XML. So we can say, let's see, URL new URL from the URL string. URL, let's see, it's import, it's in java.net, yep. Okay, and this needs to be in a try catch, yep. Then we can say URL, we're gonna say open a connection, and it's gonna be an HTTP URL connection, which is also in net. Create, wait, did I misspell it? No, why can't you find it? Oh, it's right here. What? Create constant, oh, local variable, okay. It's equal to, and it's of type connection. I'm just gonna call it connection. There we go. All right, we got a connection. This one, you need to add a catch clause. Okay, I'm gonna add a catch clause. Okay, very good. We're gonna say that this is it's a get. Set request method to a get. Go away. That's a get. And let's see, what else do we need to do? Connection, get request. Okay, now all right, then now we need a stream. We're gonna open up a stream to start streaming the data back to us. So we can say connection dot get stream. Let's see, get, what is it? Get input stream. There we go, input stream. And this will be input stream. Okay. And I think that's it. That's all we need. Let's see. This is Java IO. I believe that's all we need. What we can do now is use JAXB. JAXB context. We could say JAXB new JAXB context dot new instance. And we're working with RSP, our RSP.class, right? And we're going to say, okay, now that you know the schema that I want to map it to, now that you know the schema, create an unmarshaller. I want you to unmarshal the data that is coming from that URL. Unmarshaller from JAXB. You can say, hey, JAXB dot create unmarshaller, and I want you to unmarshal. I want you unmarshal from the following stream, from the input stream. Okay, so and what's it going to do? It's going to retrieve an instance of a response, right? RSP. Okay, and we need to cast it to RSP. And then we can return it as a response. Okay? Right? Let's see if this blows up. So this returns for us an RSP response. And hopefully it will parse out this OK over here, right? So let's print out, we'll say system.out.println response.getStat. So getStat is this one, right? This attribute, right? So let's run this, see if this blows up. Okay. So all right, so that's the data that came back right from having parsed that, right? Everything okay? All right. So let's parse the rest. The rest looks like RSP has one instant of photos, right? So let's create that. Let's go to RSP. It looks like it has a private instance of a class of a data model for photos. So photos. Okay, the class doesn't exist, so I'm going to say create it. Oh, doesn't create it for me. Anyway, I'm going to create the setters and getters for this. Setters and getters. Are you creating me? Public photos get photos. Return this dot photos. And then public void set photos. Photos. This dot photos equal photos. There we go. All right. Return this photos. Photos can have, okay, so we need to create a class called photos. I don't know why my IDE is not letting me create. I'm going to say just create one here. I'm going to say new class called photos. Photos. Here we go, photos. And it has the following attributes: page, right, total. So let's do a couple of these. Let's not do all of them. Let's do page and total. How's that? So we'll create here private string. Well, actually, it's an integer, no? So it's an integer called pages, and the other one is total. So private integer dot total, and we'll create the setters and getters for these. For both of them. Well, now it's letting me do it. Before it didn't. Okay. All right, so that's it. I think that's it. Oh, we need to tell it that these are attributes, right? So this is an XML attribute, and this is also an XML attribute. Okay, these are not elements. Right? These are not sub-elements. These are attributes. Okay. So all right. So from the DAO, the response should include the photos instance, right? So we should be able to say system.out.println, right? From the response, we should be able to get the photos dot get the total, and hopefully that will print 60,000 something. Okay. Let's run this. There it is, 60,280. Right, so it is parsing that XML from the stream, right? Converting it into a Java object model, which you can then iterate over and manipulate. Okay. One more thing. Under there, we see that photos has several instances of photo. So under photos, right? Not only do we have attributes, pages, and total, we also have another private list of photo. Okay, and we'll use list. We'll import java.util. And photo doesn't exist, so we'll create it. New class photo. And photo has what? Let's see. Photo just has a whole bunch of things, right? We has ID, owner, secret, title, farm, I believe the only one we really care about is these guys: ID, secret, server, and farm. So let's create those. Let's copy this. Let's copy this. And so we need private string ID. We need we don't need owner. We need secret. So we'll say private string secret. We need the server. This is all these attributes can be used to build the URL to fetch the actual image. Right? Flickr, the way Flickr works with the API is that they don't give you just a link to the image, right? They send you all the information so you can rebuild the URL to get the image. Okay, and so these are the things that you need to rebuild that URL: the server where the image is being stored, the secret, the farm, private string. I don't know if it's an integer, but it's better to just go safe and just assume that everything's a string. The title is optional, I guess. Private string title. And only to show you that we can parse also Boolean. These, is public, is friend, is family. Those are Boolean, right? Even though they are represented as zeros and ones. JAX-B is smart enough to understand that if you say that it's Boolean, if it's 0, it's false, and if it's not 0, then it's true. Okay, so we can let's use public. So we'll just to show you. So private Boolean is public, and let's generate the setters and getters for all these. Okay. And these are all attributes, right? So we'll have to annotate these as attributes. Okay. All right. So now in the DAO, I can get a hold of all those photos. I can say list of photo. And we call it photos. Actually, I don't need to, right? We can just say, just iterate this, right? We can say for photo P in response dot get photos dot get we forgot to put it to the photos API, right? Oh no, it is there. Do we have a getter? Oh, we don't have a getter. We need to add a getter here, right? Let's say source generate a getter for the new attribute photo. Last member. There it is, right? Now we can go back and complete this dot get photo. What's wrong? Response cannot convert from element blah 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 model to photo. What is this? Model. Wait a minute. Get photos. Retrieve that. And then what? Get. Wait, what did we did we do this right? Photos contains a list of photo. Get photo. List photo, and then class. This is in model. What's wrong? Let me see. List photo. Keys. Response dot get photos dot list of photo. Yeah. Import list. Oh, it wasn't imported. That's what it was. Dot get photo. Okay, I don't need this. All right, we got the photos, right? And what we could do is we can then print out all the data, right? We can say p dot. How about get the title? Get title. Right. Let's run this. Oops. Null pointer title. Farm. Class has two properties of the same name. Farm. Farm. Photo. Farm. Oh. Yeah. It needs to be, because these are private. So because they're private, the API can't see the attributes. Right. So actually, the annotation needs to be on the equivalent public getter. Right. So this should be XML attribute. There it is. Copy, paste. To keep it simple, what you can do is just have the attributes public, so you don't have to do this. But usually, it's considered to be bad practice to have public attributes. Try it again. Run this. There they are. So these are all the titles: Titanic, Belfast, Titanic Experience Museum, blah blah blah. If you actually want the URL, if you go to the Flickr API, flickr.com API, somewhere here, I think it's URLs. There it is. So if you want to rebuild the URL, this is our template to build in the URL. So you could say, final string image URL. Right, and then you can say, well, we need the farm. So the URL is what? You can say string URL is equal to image URL, and then you can say URL dot replace. Let's see, what are we replacing? Farm ID with p dot get farm. Right? And then keep doing it, right? URL dot replace. What else? Server ID with p dot get server. And then URL dot replace ID. ID with p dot get ID, and URL dot replace. What else? Secret. Oh no, wait. Did we do the server? Okay, it's ID. Now the secret. Let's replace the secret with p dot get secret. Okay, and then we'll do system dot out. System dot out the URL. Okay, let's run this. Okay, so these are, wait, what happened? It didn't work. What? Oh. URL equal URL. Again. There we go. So these are URLs. I hope they are kosher URLs, images that are safe to display. Okay, so that's a picture of, I guess, the Titanic, right? These are all copy paste. I don't know how that. Oh, I guess it's a little model of the Titanic, little picture. Goodbye. Oh, so that worked, right? Okay, so that's the first part. We can convert, right, to an XML document, to be able to persist, right, data models in RAM, right? When it's in RAM, it's volatile. Yes, it's temporary, as opposed to persisting it in XML, which makes it, an actual file, right? It's persisted within the file system. Okay, and there are quite a few databases that use XML as their persistent storage, as opposed to some proprietary binary representation. Right, it uses the XML format, right, to store the database. Right, it can read and write XML, right, and the queries are all done, using this XML representation. Make sense? Right. All right. So that's the first part. The first part was, here's just like we've been creating these various abstraction layers, right? Here's the last one, right? Today, right? Can we do the conversion layer between a data model, a Java data model, an object data model, and some hierarchical text-based representation of the data, of an equivalent data model? That's the first part. The other part is that this document, whether it's a stream or a file system, that might need to be converted, right? Because now we have a data representation which is a one-to-one representation. Yes, right? If there's an RSP in the XML, there is an RSP in the object model, right? If there's a photos schema elements here in the XML, there is an equivalent one-to-one mapping of the photos here, right? But oftentimes it happens that the way I represent it is different than the way you represent it, although it's the same meaning. It might mean the same thing, right? But yours might be very hierarchical, very normalized, right? Whereas my representation might be very flat. Okay, so let's talk about that, right? Before parsing it, perhaps I'll need to convert this into another XML representation before I bring it into my data model. Right? I might need to massage it, right, before I parse it. Yes, right. So let's see how to do that. Okay. So here's company, and let's go back to companies, right? And let's create several other employees in this department here, for human resources. Okay, and we'll create some. Maybe we have Alice, we have Bob, and we have Charlie, Sia, and so he makes Les, and Daniel, Craig. Okay. So for us, this is a fairly normalized data model, right? We have one company that has several one-to-many, but a less normalized version of this might be that I just list all the employees as one list, regardless of the department, right? So I want I want a flatter representation of my collection of employees. I don't want it by department. Okay, or maybe my representation is that I have a list of departments and I have a list of employees, and then I have a mapping, right, that goes back and forth. So I could have many representation, or maybe my data model doesn't use it's not using the attribute first. I actually have a better naming convention. It's first name. I don't abbreviate things, right? Okay. Or maybe I'm abbreviating this and I'm using DOH, okay? Or maybe my attribute is starting date or something. You see that? Right, so same meaning, right? But I need to do the conversion between the two. So let's do the conversion. Okay. So for instance, let's one cool representation that we want to do is convert this into something flatter, or even I want to represent this as an HTML representation, maybe, right? HTML is one of the more common types of XML documents that we're familiar with, right? HTML is a type of XML document. We can convert that into HTML. We can convert it into PDF. We can convert it into a Word document. We can convert it into all sorts of things, right? To be consumed in any different ways, right? So let's first create a simple company and extract the employees, right? So let's do that. Let's create here in the company DAO. Let's create, yeah, I guess it could be the company DAO. Okay. So let's create here, we'll say public void. I want to transform the file company.xml into another file, right? That just has the employees, for instance, right? So transform company to employees. Meaning, I'm going to give you the name of the file of a company. So company file name, company XML file name, and I want you to generate for me an employee XML file. Okay, so I will give you this file, company.xml, and you'll generate for me just a list of employees. All right, so let's do that. Okay, so let's go back here. So the way we do that is that we're going to use what is called XSLT. Right? XSLT is a technology that allows us to convert, right, or transform. That's the T in XSLT, right? Transform XML data models, XML documents, right, to or from a different equivalent representation. Okay, and the way it works is that we have to give it the two files, right? The way it works is as follows. That here's the XML that is coming. So here's the input XML, and I want to consume it as an output, right? As a different representation of the same document, right? Of the same data. But I need to transform it. So somehow I need something in here that transforms it, right? So here's my transformer, my transformation. Now we could do it all in Java. We could do this all in Java, but there's a specific language, right, that allows you to do this much more efficiently, and the language is XSL. So XML style sheets. And what these XSL style sheets will allow you to do is take an input XML document, refer to elements in those XML documents, and say, oh, I want that and the other, right? Look at all the patterns inside of that XML document and only extract those pieces that I care about. Okay, and that's what XSL, the language XSL, allows you to generate. And what you do is that you generate an XSL document, .xsl. Okay? You feed it to the transformer. The transformer will use that XSL to convert the input XML document into an output XML document. Okay? All right, so let's do that. Now the transformation, we need to do that from Java. Right? From Java, we have to say, read the file that you want to transform, read the file that has the XSLT transformation, and apply the transformation to the input file, and generate and write an output, a result XML file. Yes? So let's read these three files. We're working with three files. Okay? The transformation file, right? So that will be an additional, so string, the XSLT XML file, right? And so we'll say Okay, well, let's read all these files. File, the input file will be new file, the company XML file, right? We'll read we'll create an output for the output, right? Which is what? Employee. We'll say output file, new file, and this is the employee, I think. Employee, there we go. And we'll need another file for the transformation. We need to read that as a file as well. So that this is the XSLT file, new file, XSLT XML file. There we go. Okay, we got the 3 files going. Oh, yeah, I've just read them in. Well, not this one, right? I haven't read this in. I'm going to write this file. Okay, so these 2 are input. So let me put them together. There are 2 inputs that I'm reading, and I'm going to write the 3rd one. Okay? Okay. So to do that, we need to have the API, the transformation API, right? The XSLT API, read those as sources. Okay. The transformation API is under import javax dot XML dot transform. There it is, under transform. Okay. Right under there, that's where the XSLT transformation API lives. Right. We're also going to need to read these files. So transform, and those are under the stream. Right? Under the stream, there's a couple files. The 2 that we're going to use is these 2, stream result and stream source. So source is the ones you're reading, and results are the ones that you are writing. Okay, so these 2 streams are used for reading these 2 input files, and the result is for writing this output file. Yes? Okay, so let's do that. So what are they called? Oops. It's a stream result and stream source. Okay. So stream source. This is the input source. It's going to be new stream source that takes as argument the input file. Okay, and it's going to also read source the XSLT source, new stream source, the XSLT file. Okay, and it's going to generate a result. So it's going to be a stream result. So this is going to be an output result, new stream result that takes as argument the output file. There we go. All right. Okay, so these 3, what this will use to read those files and parse them as from XML documents and make sense out of them. And this will know how to generate XML files. Okay, the transform. All right. Okay, so now what we need is the actual transformation. We need to actually transform. To do that, we need a transformation factory, very much like everything else, right? All the entity managers, right? These all have factories. Factory is a design pattern. What it does is that it, in general, the factory pattern is so that instantiating an object might be fairly involved. Okay, and it might take quite a bit of things that you would need to do to instantiate an object. And what factories do is that they encapsulate all that logic of creating and instantiating objects, and they provide you with a clean API to instantiate these objects. So instead of you saying new, where to create one of these transformers, you would have to have a fairly number of news, right? New this, new that, and set and configure quite a few things. Factories, hide all this details of what needs to be instantiated in what order, right? And they hide it under a nice API. Okay, so we need a factory. Transformer factory dot new instance. Okay, And now we can create a transformer. Factory new transformer. And we're going to say, and this is going to be a transformer that knows how to transform, right, using these rules, the XLT source. So that I'll give it the source only once, right? Right. I'll give it this XSLT only once, and then it'll be able to transform any instances of these documents. Right? These documents, presumably, they all have the same schema, right? So the same rules can be applied to any number of instances of these documents, right? For the same transformation. Right? This is the equivalent of a program, right? This is the equivalent of some algorithm that's going to be applied to some input data, right, and generates an output data, a transformation. I mean, that actually, isn't that what an algorithm is? That's all we do, right? That's all computer scientists do, right? They're always writing some kind of transformation, right? That will take some input data, right, and generate some output results. Okay. The thing is that the language here is different. We're not using Java to do the transformation. We're using XLT, which we'll do in a second. We'll use it in a second. So so you can consider this as like the compilation time, right? We're compiling, right, this transformation, and then we can apply that same compiled set of rules to any number of input data, right, and transform it to whatever result that we get. Make sense? Right. So that's kind of you can. You know, the analogy here is that we're compiling the XLT code, and now we can actually transform the XML input, the input source, into the output result. Meaning this will apply that XSLT to this input, and it will generate that output. Make sense? Right. This, I think, throws exception. Try catch, and this needs to be in here. This generates other exceptions. There we go. All right, so we have that. All right, so let's see. Okay, let's not do that. Let's not do this. We're not going to parse the company. Well, instead, what we're going to do is we're going to call DAO dot transform company XML to employees dot XML using transformation. We'll call it company to employee dot XML. Which we don't have, right? We don't have this document. Right? We need to write this, and this will be XSL. We need to write this. Once we write it, this will apply these rules to the company and will generate employees. Okay, so let's write this. Let's write that. So we'll say I want a new XSL, there it is. And the name, that's it, .xsl. There it is. It's empty right now. Okay. Let's see. So the way this works is that the way XSL works is by pattern matching, right? And it will look at the input document, which is a company. Well, let me close a couple of things here. Let me close this. Flickr, RSP, photos. Right. It will take the input company. And it will pattern match. Right. It says, here's a whole bunch of templates. It says, okay, match according to these strings over here. Right. Now these strings over here, right? They use a hierarchical system, right? Where you could say, slash something slash something slash something slash something, right? And what they do is they look very much like a path, don't they? Right? It looks very much like a path that you would follow in a file system, maybe, or a name in a URL. Yes. And but what they do is that they match the hierarchy of the incoming document. Okay, notice that this is a hierarchical document, isn't it? Right. This is kind of like the root. Yes. So the company is at the root. So slash, okay, kind of matches everything. It's everything. Then slash company slash department slash employees, right? Those slashes, right, and names, they allow you to refer, right, to any elements of the input document, right? You can say, okay, I want to pattern match, you know, this date of hire over here. Where is date of hire? How do I pattern match date of hire? Well, date of hire is what? Slash company slash department slash employee slash date of hire. You see that? So this pattern matching over here, this path, you know, it has its syntax. Yes, the syntax is slash element slash element slash element, right? Allow you to hierarchically refer to any element in the incoming document. And when the pattern matches, what you can put in here is, what do you want to generate if it matches? What do you want to generate in the output if it matches? So let's keep it simple and let's say just a hello world. So slash matches the root. Well, all XML documents, well, all well-formed XML documents have a root, right? So this will match anything, right? It will match, you know, if the incoming XML document is correctly formed, right? It will match anything that it comes in. So the output in what file? The output in employees.xml should just say, according to this rule, should just say hello world. That's all it should say. Okay, so let's try it. So let's run this. Okay, it didn't blow up, so perhaps it worked. Let me refresh. There it is, employees. There it is. It just says hello world. Right. So the top says this is an XML document, right? And the only thing that I've generated so far is just hello world. Make sense? Right. That's all it generated. Right. So if I change the rule, right, you know, whatever I type here, right? If I run it again, there it is, right? So it generates, it matches the slash. So anything I put in there, it will generate it. Very good. So I could say, well, what I want to generate is a list of employees. That's what I want to generate. Okay. I want to generate an output document that has a root of employees. Right. So if I run that, and we go to employees, there it is. So it generates for me an open and closing of the employees tag. It's empty, it has nothing inside, right? So it opens the element and it closes it right away. Make sense? If I put something in there, you know, employees something, right? And I run it, wait, did I run it? Employees, something. Okay, there it is. There it is, something, right? So notice that it opened and closed it. See, at the beginning end it has an opening and closing tag because now the body contains something. Yes, right? Very good. All right. So what do I want to do? What I want to generate in here is the list of all the employees, right? So what I want to do is go back to my company and basically, where are all my employees? My employees are, let's see, here's one, here's another one, here's another one, and there's 4 employees here, right? So what I want to do is iterate over all of them. I want to pattern match all the employees and extract first and last and maybe the salary. Okay, so I could say here, I could say, okay, in the XSL, we can say, all right, I want you to pattern match. Notice that I have tags here, right? This is an element. This is also an element. You see that? Right? And the way the rule engine distinguishes them between the types of elements is that these have the XSL colon namespace in front of it. You see that? What that means is that, hey, this is like a meta tag, right? It's not meant to be generated to the output. It is part of the programming language. Yes? Whereas anything outside that does not have an XSL colon in front of it is considered to be, you know, a verbatim, right? It's supposed to be a static piece of text. Yes? You know, very much like if you're doing a JSP, right? What do? Sometimes you're generating HTML, right? But then you have to embed Java, right? And to be able to distinguish between the two worlds, between the two languages, you put Java in those funny pointy brackets with a percentage, yes? It says, oh no, well, this is Java and this is HTML, right? Anything outside of the pointy brackets, right? It's just plain text, and anything inside of the pointy brackets % is Java. Same thing here. We need to be able to distinguish between what's the program, right? What's the algorithm, and what's the text that it's generating. Yes? So all these, right, these that starts with XSL are part of the algorithm, right? The rules, the rule engine. Okay, so employees. So what I want to do here is that I want to iterate over all the employees here. So where are the employees? They are under company / department / employees, right? So let's iterate over that. I'm going to say XSL : so here you have all the options. This one, for each. For each allows you to say, okay, pattern match any number of elements, and then for each one of those that match, generate the following content. Okay, so I want to pattern match and says for all the company / what is it? Okay, keep you awake. Company / department / employees. Okay, for all those that match, how many match? Well, that path here actually matches a whole bunch of them, right? It matches this, right? That one right here. It also matches that one right there, right? It actually also matches this one, and it matches that one. All four match, right? Across several departments. See that? Right? It will pick out all the four, right? It will iterate over them. Very much like what other language does this that you might be familiar with? jQuery does that, right? Anybody use jQuery before? jQuery does the same thing, right? You can give it a path, right? But you use another language there. You use CSS, right? The CSS language. CSS language is a subset of XSLT, right? CSS, right? Cascading style sheets is a simplified version, right, of XSLT. XSLT is like the big daddy, right, language for manipulating HTML or referring to XML elements, and CSS is a subset of that. Okay, for instance, CSS doesn't have loops, right? It doesn't have if statements, doesn't have variables, right? So it's a subset of this. Whereas over here, you do have loops, right? You have variables. You can do math. You can do all sorts of cool things, right? So yeah, so XSLT is the granddaddy of the style sheet language. All right, so anyway, so I'm looping over that. And what do I generate for each one of these? I want to generate, for each one that matches, I want to create an employee tag, right? Let's see what that does. Let's run this again. And let's format. There it is. So there were 4 employees, right? Right. So notice that it generates 4 employee elements, 1 for each employee. See that? Okay. But it doesn't have anything because I never put anything in there, right? So I'm going to put something in there. Inside of the employee, what do I want? I want to generate another tag called first name, right? Because my representation of an employee is the attribute first name, last name. Yours is first. My representation is first name, right? It's all spelled out. It's camel cased, right? And last name. So last name. And maybe salary. There we agree. So we generate again. We run it. Wait, what? Did it run? There we go. So it's empty, right? Employee, first name, last name, salary, right? What we want to do here is put data in there, right? Put the actual data in there. So we want to extract the value or the data that it was originally in there, right? So for instance, we want to extract this Charlie, this Garcia, this whatever, right? So what we want to do here is say, all right, now we are within the context of the employee, right? As we are iterating, right? Each one of these will be within a different context, right? The first one will be for the first element that was matched, right? And then as you iterate, it will pattern match, each one of the employees. Yes. So what we wanted to put here in the first name, we want to say, well, I want to extract. Within the current instance of employees, I want to extract the value of the element first, right? That's inside of that, so we can say first. And for last, I want to extract last. This is me doing the mapping, right? You call it first, I call it first name. You call it last, I call it last name, right? So that's my mapping. And salary, I think it's called just salary. Yeah, it's also called salary. Oops. Oh, salary. Okay. So now we can run this again. There it is. Alice, Wonderland, Bob, Charlie. You see that? Yeah, that makes sense, right? Notice that it's flatter, right? It's not by department. Okay. Right. So here was an example of generating, XML to another XML, right? How about generating something else? So for instance, we can say DAO.transform company, the same XML, company.xml, and I want to generate on employees.html. How's that? We can generate HTML instead. Any more interesting? We'll call company to employees. Company to employee HTML.xsl. So we'll generate a different list here, a different rule, but that will transform the incoming XML document into an HTML equivalent. Okay? So let's do that real quick. Let's create another XSL document, another one. File, and say new. XSL. Right, and so what we want to do is, at the top, right, with at the root, what I want to generate is kind of the boilerplate of any HTML document, right? What do I have? Like we have HTML, right? What else we have? We have head, right? We have body, right? And in the body, maybe we have, you know, H1 employees, right? And maybe I want it in a table format or in a list format. Let's do the table first. We'll say table, right? And we want to generate a T header, T head, right? And maybe we want a table row with TH that says, maybe I want to show what? Let's see. I want to show the company. Company. I want to show the department. I want to show the employee first name. Employee first. Oops. Last. Keep it up to there. That's it. And then in the body of the table, what I want to do is create a table row for every employee that I find. Yes, right? Since that's an iteration, I'm going to do a for loop here, right? Actually, let's just do this. Let's see what it generates so far. Let's run this. And it should have generated an HTML document, employees.html. So let's do a function refresh. There it is, the HTML. Here's the HTML. Notice that, right? It generated the HTML, the head, the body, H1 table for the header. We can actually open it up with an HTML browser and see what it looks like. Okay, so it looks like that, right? That's my table. Right? Save that. Let's keep writing this. Let's see, what's my rule? In the table body, what I'm going to do, I'm going to iterate over. I'm going to iterate in for each. What's for each? There it is. I'm going to iterate over company slash what? Let's see, company slash departments. Is it departments? I forget. Or is it department? Employees? Is that it? Company, departments, employee. That's why I never like to use plurals. You never remember if you use plurals or singulars or. Okay, so where were we? Here we're here, right? So departments, employees, and as I iterate over that, I want to generate a table row. And in that table row, I want to generate first in my table, my first table data. I want to generate what? The company name. Yes, the company name. But I'm under employee. You see that? I'm iterating over employees. Where's the company name? It was way up on my parent, isn't it? Right? If I'm iterating over the employees, I'm way down here. Where's the company? Is way up here, right? And the name of that company is inside of the company. So I would need to, you know, as I find this employee, I would need to go back 1, 2, and then down to the name to retrieve the name of the company, right? Okay. Well, we can do that. We can say, you know, now that you're within the instance of a particular employee, I want to go up 1, right? If I'm an employee, if I go up 1, where am I? In the departments, right? If I go up again, now I'm in the company, yes? And then I want to go down to name, right? Into the name of the company, so name. Oh, so that allows me to extract the name of the company. Let's try that. Let's run this again. There it is. So they're all ABCs, right? Because all the employees work for the same company, ABC, right? And we can refresh this. Yeah, ABC. So this one is also very flat, right? Because we're generating something that comes from something that is hierarchical to something that is flat, right? So, and when you do that, you are denormalizing, right? So you have this redundancy. You can see the redundancy right here. you're capturing the name many times, the redundancy. Whereas in the original data model, right, it was very normalized, right, and the name of the company was captured only once, right? Okay. All right. So let's keep going. We want the name of the department. We can say TD. Copy this, and we're gonna go up one. If only we'll go up one, it breaks you to the current department that we're in, right? And we get the name of that department. So let's run that. Let's see what we get. Let's refresh. There we go, right? So we have 2 of the employees are engineering and 2 of them are in human resources. Again, flat, right? We're denormalizing. We'll go back here and then we can extract the, what is it, first and last. So let's copy this. So we are in the instance of the current iteration of a particular employee. So we are already there, and we can retrieve the first, right? And we can retrieve the last. Let's run that, and let's refresh this. There we go. All right, so we extracted the content, right, in a flat. Now, somebody might say, well, you know, we could also maintain their hierarchy. Right? We don't have to necessarily, right, convert this from something that is normalized into something that is flat. We could maintain the hierarchy by using other representation of the data, even in HTML. We could instead, right? So we could say that this is the H2, you know, tabular representation, but we can provide here a hierarchical representation. So hierarchical. Is that spelled correctly? I don't know. What we could do is actually use UL, right, and use the nesting properties of UL to retrieve this, right? So what we could do here is use here, retrieve here the value of, and pattern match just the company name. Oh wait, sorry, this needs to be inside of an LI, right? And this needs to be inside of the LI. There we go. So if you run that, okay, right, we have the name of the ABC, of the company ABC, right? And then we can nest these things together underneath, right? So we could do something like inside of here, we can generate another nested UL, right? And then use and then generate several LIs for the pattern matching of all the departments, right? So we could do, you know, we could do match the for each. We could say for each, you know, pattern match company slash departments, right? And as you pattern match that, generate an LI for each instance, right? And in here, I want you to put the name of the department, right? The name of the department, right? So if we run that, okay, notice that we have now ABC, right, and then the hierarchy of all of the two departments in there. We can close that. Then inside here, we can go one step further and generate another UL, right, and iterate over all the employees, right? So this is the XSL pulling for each. Pattern match the company departments slash employees. Okay, and for each one of those, I want you to generate the LI for the name of the, right? So XSL value of the first name, just the first. Right. So if we go back and run this again. There we go. Oh, no, wait a minute. No. Wait, what? Oh, no, we have to, within here, company. All right, so for each, all right, so we are inside of the departments. We don't want all the employees. We just want the employees within the departments. Okay, that should work. Run that. And let's refresh. There we go. So within the engineering, we have Alice and Bob, and within the human resources, we have Charlie and Daniel. Okay. So we have, you know, we can maintain the hierarchy representation on both data models, or we can flatten it, and we could go vice versa. We can go from a flat, right, and generate a more, you know, we can use grouping to group these things and know that that all of these all belong to the same company, and that these two are grouped inside of the same department, right? But anyway, we'll do that next year. All right, I'm going to leave it here. So we have some time to talk about the midterm.